Hello everyone, we're going to be presenting our idea for this ideathon. We're presenting a multi-agent energy revolution, focusing on balancing hybrid grids and meeting the demand in real time using MARL with self-attention. The core of our idea is to move the grid control paradigm from rules to intelligence. Our energy grids are changing fast and the current systems simply can't keep up. Now, in today's market, there are existing hybrid plants which combine solar, wind, and thermal with storage to maximize renewables. They're controlled by centralized systems like SCADA, which operate based on fixed rule-based logic. However, this rule-based approach has major limitations. It doesn't work as well, and it's not as efficient and sustainable. Variability struggles with the unpredictable nature of the solar and wind output, and there's not much coordination. The rigid rules make it hard to easily adapt to the changing environment, and it can also lead to suboptimal renewables usage and difficulty scaling with growing renewable penetration. There are existing demand response systems, according to this, which adjust the consumer electricity usage to balance the grid demand with supply. However, this is rule based, of course, and it's AI powered, but it's rule based. It is rigid and it doesn't have a steady system. It can lead to limited interaction with supply storage for dynamic balancing, and it struggles with large scale diverse consumer participation, and moreover it doesn't have a prioritization system which can prioritize critical loads in certain areas like hospitals. This is our solution for this major problem that we are facing right now. We need a system that is adaptive, fast, and coordinates dynamically in real time. Our solution is agentic grid balancing. We treat every component as an intelligent AI agent. The agents we're going to be using, of course, are solar, wind, which act as renewable energy resources, thermal resources, which act as non-renewable, battery for storage, and the demand response accordingly. And the engine we're going to be using is multi-agent reinforcement learning with MADDPG. This allows them to learn optimal actions through centralized training and decentralized execution. Now, the main part we're going to be focusing on is self-attention. They don't rely on a central controller. They dynamically focus on relative peers for smarter real-time decisions. We're going to look at how it improves next. It is adaptable. It adapts to the real-time data without having a rigid and incohesive system. There is a lot of coordination between this, and thus it is more efficient when it prioritizes renewables more than the non-renewable resources, which can make it even more sustainable for the environment and an increased growth of scalability. This is going to be our AI approach. The AI approach we're going to be using is mainly focused on reinforcement learning. Now, reinforcement learning is a type of machine learning algorithm that uses trial and error for the better optimization of the overall system. The agents that we're going to be using, we have mentioned before, and in it we're going to be using a type of a reinforcement learning, which is MARL, which is multi-agent reinforcement learning. This allows it to collaborate and manage the grid, and we're going to be executing it using centralized training to coordinate the learning, but decentralized execution to ensure they act independently and fast in real time. They act as an individual agent and they act independently according to it. This is CTDE. And the last thing we're going to be using is self-attention. This mechanism allows the battery agent, for example, to dynamically prioritize signals from the solar agent during surplus, significantly improving coordination and efficiency. The MADDPG reinforcement learning algorithm is designed for the continuous action spaces. Now, these are the agents driving the solution. For example, when the solar agent peaks, the battery agent prioritizes that signal for charging. And when the demand peaks, all the agents instantly adjust their focus to prioritize signals from the critical load areas. This is real-time, flexible decision making. The workflow you can see shows the continuous learning loop. It starts with collecting the real-time data, and then the agents select the optimal action to adjust the supply, and then update the learning policy. The simulation result, you can see that the red line, the thermal line, it has a height. It prioritizes the non-renewable resources more, which can lead to the unsustainable part of the system. And with agents, you can see that it's highly minimized with the demand line, that is the pink line, making it equal to the battery efficiency. You can see that also it is built on proven success. The current hybrid systems, they save up to $40 million per year, but with our AI enhancement, there's a 30% efficiency, allows us to increase the sustainability factor of the system. Now, when you move on to the prototype. This is the prototype that we have right now, and this prototype is on the basis of what we have built. You could see the agent status, and if you go into the agent view, you could see a lot of other stuff with all the agents, with the percentage of coordination and the percentage of prioritization we have right now. And you could also see the solar agents and how much and the current state of what they're in. This is our presentation. Thank you for listening.